Today we're going to discuss about stack. What is stack? We call stack as the concept of last in first out, or sometimes we call it LIFO, L-I-F-O. So we are going to learn what is the abstract data type. So you know, when we learn about the object oriented, we learn one section about the abstract data type. So we will learn about the example of stack and some stack to optimize the complexity. Okay, the concept of stack is last in, first out. Whenever we have the data structure, this is what we will make the abstract data type. The abstract data type is an abstraction of a data structure. It means in the ADT, it will specify the data stock and then the operations on the data and the error condition associated with operation. So the ADT, it is a kind of abstraction for a specific data structure. In this case, if we want to model a simple stock trading system, if we want to model the simple stock trading system, we know that whenever we have the data, we want to buy or we want to sell. Okay? This is for the stock. Then it means the operation will be buy. Buy means how many stocks I want to buy. No, sorry. What is the stock that I want to buy? How many shares that I want to buy? And then what is the price? Or if I want to sell, then it's also the same. What stock that I want to sell? How many shares that I want to sell? And what is the price? And there will be a cancel. Let's say I cancel my decision. So those kind of operation, you can build in the ADT. And we need to understand the error condition. The error condition means something that will cause the error. For example, the stock is not available. Okay. Maybe you will have 1,000 shares, but you want to sell 2,000. So you need to give some message. Or if you want to buy a stock, but the stock is not available. Maybe the stock is not available in Korea, the stock is available in other countries. So you need to give the error condition. Or there will be a cancel of non-existing order. So maybe when you click buy, the internet connection interrupt the process. And then you want to cancel the buy process. But because the order is non-exist, so you cannot cancel it. So this kind of thing, you can make some abstract data type. And the simple data structure that we need to learn is the stack. So stack, or we call it stack ADT, it stores arbitrary objects. So you can use any kind of object, you can use any kind of application. And the concept will be using the stack ADT. So the idea of the stack ADT, we have the insertion and deletion. I guess you already know when we learn about the array. When we have the array, when we learn in the array section, we have the addition. Okay. We can add or we can insert an object or an item. we can delete or we can remove. So with this kind of operations, we can also do it with the stack ADB. So these two operations, the insertion, the deletion, will follow the last in first out scheme. So it is similar like, yeah, people say the spring loaded plate. When you put something, it will go down, it will go down, it will go down until it reaches the bottom. And then if you want to pull out this spring load plate, then the plate will be from the top. The plate will be from the top. The plate will be from the top. So the main operation, we have push and pop. The push means whenever we have a kind of bucket, we can push the object. So we want to stop. Let's say I'm going to save the item number 1. I want to save item number 2. I want to save item number 3. I want to save item number 4. I want to save item number 5. I want to save item number 6. So we call it as push. So after we push, it means it will have a stack. The stack number 1, stack number 2, stack number 3, stack number 4, stack number 5, and then at the end stack number 6. Whenever I want to pop, so the push object means I would like to push a particular object. So it means I want to insert an element. If I pop it, then it means I would like to remove and return the last inserted element. So if I already have this kind of stack, 1, 2, 3, 4, 5, 6, once I pop, it means the last element will be removed. 6 already removed. So if I pop, then the last element, which is 5, will be removed. If I pop the next element, the last element, which is 4, will be removed. And so on until the last element, which is in the bottom. So the main operation will be push and pop. But there can be auxiliary stack operation. It means additional. The additional operation is like top. I want to know it returns the last inserted element without removing it. So if I call top, I want to know what is the last element or what is the top element. If I call length, I want to know how many number of elements stored in stack. If I have is empty, I can know whether this stack have elements or not. So you can see, usually whenever we do with this kind of ADT, we will specify object. It means when I call this method, it will show you the object, whether the object name or maybe the object index. I have integer. So when I call this method, it means I will get the integer value. Whenever I call this method, it will return Boolean. So, for example, it starts with the S. S, let's say this is the empty. Okay. So the stack content will start with empty. S dot push 5. Then now the list have one element 5. S dot push 3. Now the list will have 2 elements. The first element is 5 and the next element is 3. Now I want to know the length of S. The length of S is 2 because we have 5 and 3. We have 5 and 3. And then I want to pop. What does it mean by pop? We want to remove. But we also want to show what is the object. The top means the last element that we inserted. The last element that we inserted is 3. Then the return value will be 3. The object 3 will be removed, and now the element becomes only 5. I would like to check if S is empty or not. S is empty? No, because I still have one element. So the return value will be false. S dot top. So I will remove the top element. The top element is 5. It will return 5, and then now the list becomes empty. S is empty because it is empty, so it will return true. S dot pop, it is error. Why? Because we have no element. So nothing to be removed. We want to push, then there will be a new element, 7. We want to push, then there will be a new element, 9. Top. So I want to know what is the top or what is the last element in the list. It will return 9, but the element still same, because we just want to know what is the last element without removing it. Push 4. So the next element will be 7. The next element will be 7, 9, and 4. What is the length? It is 3, because we have 1, 2, 3. I want to pop, so I will remove the first one. 4 will be removed, and the remaining will be 7 and 9. I want to push, so I will input a new element, which is 6. I want to push 8. I have a new element, which is 8. And I want to pop, so it means I want to remove the last element, which is 8. Okay, so this is the step by step for the stack. There are many applications that they apply the stack. For example, when you use the web browser, you can have this kind of idea. What is the first web that you visited? And what is the next web? What is the next web? What is the next web? And then if you want to go back, you can go back to the previous one. Okay. You can go back to the previous one. You can go back to the previous one. Or, you know, in the text editor, you have the undo. So it also uses tag. Chain method calls in a language that support recursion. So when you do the recursion, it's also a kind of, you can also apply stack for the recursion. The indirect application, it means you can use stack for different kind of data structure, or you can use stack for different kind of algorithms. And stack is a component of other data structure. For example, we can use stack in an array. A simple way to implement the stack ADT is using array. We can add the element from left to right. So the index will start from 0, and then 1, and then 2, and so on. And a variable keeps track of the index of the top element. you know, when we use the list, we have index. Index 0, index 1, index 2. So the last index will be the top of that list. The array storing the stack elements may become full. So you already know when we use array, it will be fitted into the number of elements. If the array is full, then you need to grow the array. So we learned two basic strategy for growing array. Do you still remember? What are the strategy for the growing array? There are two. First is the linear strategy, and then here the doubling strategy. So the linear strategy means we will add the array as constant. If doubling strategy, it means we will add the array as the double. Or we can say for the linear strategy, it will follow the arithmetic. For the doubling strategy, it will follow the geometric. This is based on the sequence. For the performance of stack, let n be the number of elements in the stack. So if I have the bucket and then I put the item like this one. So the space that we use is ON. So if there are n elements, of course, the space that we use is n. Each operation runs in O1. This is amortized in the case of a push. So whenever we push one operation. We push, then second operation. We push next item, then one operation. So the operation is one, simple. That's why people try to adopt this one in many kind of applications. I give you also the code. Okay, I think we will take a look on the code later after we understand the concept about the stack. So if you look at this one, if we apply the array, we will make a class, and then we will make the constructor, and the constructor will have a new data member, and this data member will use list. I would like to make a new function to check the length. So this means I want to know how many data are available in the list. I want to check whether the data is empty or not. So the length, if it is 0, so if the length is 0, then it is empty. If it is not, then it means, yeah, you will just always give false. And then if you push, it means you want to append. If you want to see the top, it means I want to see the last element. But before that one, there should be a kind of exception. If it is empty, so you can just mention the stack is empty. And we will return the data -1. What is the data -1? We know that this is the last element. Okay. And then if we pop, it means we want to remove the last element. So if the stack is not empty, then we are going to pop it, remove the last element. So there are some examples of the stack. The first example about the parenthesis matching. You know, parenthesis. Whenever we make a parenthesis, okay, this is the opening. There should be an ending. If we create with this curly bracket, I call this is the curly bracket, there should be an ending. If we have the square bracket, then there should be also an ending. Okay, and this should be in a pair. It means this one should have this one. This one should have this one, and this one should have this one. So let's say if I have this is an opening, this is ending. Opening, opening, ending, ending. Opening, ending. Opening, ending, opening, ending, opening, ending. Okay, this is correct. But how can we check it with a stack? So if it is more complex, it's very difficult to check by eyes. So you need to build an algorithm to check whether those kind of parentheses already match or not. For the third one, it is incorrect because, yeah, we can see directly from the first one. It starts with closing, without starting. This is also incorrect because the sequence has not in the order. This is also incorrect because there is a starting but no ending. So we can make this parenthesis matching algorithm. The input is an array of n tokens. So yeah, you can input this one and then this one and then this one and then this one and so on. So the output is true if and only if all grouping symbols in X match, okay, or maybe we call it the pair matches. If the parenthesis match like this one, it is parenthesis match or the square bracket match. So you can take a look on this one. This is the algorithm. Okay. Yeah, this is the example that we can use in Python. So this is a function is match, and then we have the expression. We define the left and we define the right. So the book authors have made a new function which is array stack that we looked at before, and then for those array we want to make a kind of list. So if C is in the expression, it means we want to look at the data, and then let's say C, I want to know if C is in the left. What is left? These are components. If C is in the left, then I would like to push C into the sequence S. If it is not, then I would like to check whether C is in the right. If C is in the right, then check if it is empty, then it will false. If the righty index C is not equal to the lefty index S pop, then it will false. So it means if empty, we don't have any match. If it is empty, it is mismatch. So the last one, if we cannot find anything, just finish with the return is empty. Usually we can use this one as the tag matching, especially in the HTML. So if you learn the web browser, you can learn about the HTML, and then in the HTML you need to have the starting and ending. For example, I have the starting name, I should have also the tag ending tag. So for example, here the body, I have body as the beginning of the tag, I should have the body as the ending. So I need to make this pair. I need to check center, so this is the ending of the tag. This is the starting, this is the ending. And we can make the HTML tag matching with the algorithm that we looked at before. If we use the HTML, then we also need to match it with the HTML. For example, in the HTML, we use this triangle bracket. We use this triangle bracket. If we use this triangle bracket, for example, body, and then at the end we need to close it with the slash body. So I want to know whether a tag like this one is followed with the ending tag like this one. I can make a new function, and then I will use the array tag, and then let's start with the opening like this one from the any line in the HTML. So raw means the parameter, or this is the data that we are going to use. So let's assume that this is the HTML file. So the HTML file will be something like this one. So if j is not equal to -1, first I would like to find the character, this one. So if it is not -1, it means I can find at least 1. If you cannot find this character, it means, okay, this is not HTML. So as long as it is not equal to -1, then we will do this loop. First, we want to find this closing. And then, we will do the j plus 1. So j will be added by 1. And then, if k is -1, it means if we cannot find it, return false. I would like to check the tag. It means the row, this is the row, j plus 1 until k. So I want to check the element from j plus 1 until the k, until we find that element. If not tag starts with this one, so it means if we have body, this is the opening, and then if we have slash body, it means this is the ending. So if it is not started with slash, it means this is opening tag. If it is started with this one, then it means this is closing tag. And then you will check whether S is empty or not. If it is empty, then false. It means it does not match. And then I would like to check the tag from 1 until the remaining. If it is the same with the pop or not. If it is the same, then if it is not the same, then return false, or we call it, this is the mismatch delimiter. So we will go to the next, which is k plus 1. So we set the j as the raw, find the next triangle bracket. And at the end, we will check whether it is empty. The other kind of application, we can try to use the calculator. When we use the calculator, we can evaluate this arithmetic expression, and we can think that this is a part of stack. 14 minus 3 multiplied by 2 plus 7. When we have this kind of arithmetic, in Python, they follow the operator precedence. What is operator precedence? There are some rules. Multiply should be first, and then plus, and then minus. So here we have multiply should be first, and then plus and minus. So I can make it in more detail like this one. Multiply we'll do first, and then we will check from the left to the right. So 14 minus 6 plus 7. So we will need to understand this associativity. When we have the operators at the same precedence group, which is like the positive and negative, plus and minus, then we will go from left to right. From left to right means x minus y plus z, not x minus y plus z. So the idea is, if we have the stack, we want to push each operator, this one, to the stack, but first stop and perform higher and equal precedence operation. So we need to check if it is multiply or division, and then we can do the operation with plus and minus. So for this purpose, we can make the stack, and we can develop the stack with two stacks. For example, the first, it will be for the operators, or we call it OPSTK. This is the stack for operators. And then we have value STK. This is the stack for the values. So if we have 14 minus 3, then the minus will be for the operators, and the value will be for the variable values. So you can define anything. At this example, they want to use the dollar to be a special character to indicate the end of input. Now the algorithm do operation. It means I will check the x, I will check the y, and I will check the operator. So if I have 14 minus 3, then the first will be the numbers. This will be the numbers, and then this will be the operation. So the operation later we will check the operation will be the new value will be a push of y operation x. We will do the repetition if we have the ref op. It means whenever we have the while, okay, if the value is still higher than 1 and the precedence of the op is less than or equal to the precedence of the operation stack on it. So this is to check whether the plus is higher than the multiply or multiply is higher than the plus. So yeah, we are going to use this algorithm to op and repeat ops. So the input will be a stream of tokens representing an arithmetic expression with numbers, and the output will be the value of the expression. So this is the overall algorithm. While there's another token Z, so another token means, yeah, if we still have like this one plus 5 like this. So is there any token? Yes, then we will do this. Is there any token? Yes, we will do. Is there any token? Yes, we will do. So token means we have a character or we have a number. First, we will check if is number. Okay, is this a number? Yes, then push it into the value stack. If it is not, then we will do the repeat ops. Means I want to know what is this operation. So the repeat ops means I want to know what is the precedence, whether it is higher than the multiply or it is lower than the multiply. After we know this one, we will push into the operation stack. So this will be done in the while loop. The last one, we will have the repeat ops with the dollar sign. So if it is the dollar sign, then we will finish. Finally, we will check what is the last value. I can show you with this kind of animation. So I want to check 14 less than equal to 4 minus 3 multiplied by 2 plus 7. Operator less than equal has lower precedence than plus minus. So what I can do now is I have the form. Okay, this is the value stack. This is the operator stack. So I have 14. I will input it into the value. And then, is this a value? No. Then I will go to this one. Is this a value? So it will be here. And the 14, between 14 and 4, we have one operator, which is less than equal. So we put in the stack of the operator, and we put the minus into the operator stack. Because we know that this one is the less than equal is lower than plus and minus. So we go. We can check the next operator and we check the next value. We put into the stack, and then we input to the number here. However, when we have the plus, so plus with the multiply, which is higher, multiply is the higher one. Then we will not put plus into this one, but we will do the operation between 2 and 3 with the operation multiply. After we have the result 6, then we will put the plus for further consideration. And then the plus, we will check minus and plus, they are in the same rule. Because they are in the same rule, so based on the mathematical rules in the programming, we will do from the left to the right. Then we will do this one first. It means 4 minus 6. The result will be minus 2. And because plus and minus is higher than the less than equal, so we put plus here. So we need to check. The remaining part is 7. Then we will have the 2 and minus 2 and 7, and there is no other operators. So we can just put the dollar sign to indicate this is the final states. Because this is the final state, so we can just do the 7 plus minus 2. So it is 5. And then the last part, we can check between the number on the left and the number on the right with this inequality sign. So we have 14 less than equal to 5. It is false. The result will be shown as false. Okay. So that's the step by step for the stack operation. Stack can be used to optimize algorithm. Yeah, not all algorithms can be optimized, but some algorithms can be optimized with stack. Let me explain on Wednesday, because I think I need more time for this one. Okay, any questions?